Okay, it's my pleasure to introduce our next speaker. Dr. Salman Malakpoor is an academic member of the Coldwater Fishes Research Center of the Iranian Fisheries Sciences Research Institute. He received his PhD from the Interdisciplinary Center of Marine and Environmental Research of the University of Porto in Portugal, where he also completed a postdoctoral training. He is a broadly trained biologist whose primary interests are in the effects of environmental factors on the physiology and biology of aquatic animals, with a particular focus on ion transport mechanisms. So thank you very much, Salman. You can start your presentation.
Sure. Thank you. Hello, everybody. And sorry because of my delay. I still have internet problems. Anyway, let's start because of the time. It's actually this presentation belonging a small part of my PhD that already done at Porto. At the moment, I'm living in Iran, and this is a night. Probably you can see dark in my background. Anyway, I'm Greg. I'm going to talk about marine. This is the unit. All of it. Currently, I work here. This is the Coldwater Fisheries Center in North Iran. It's located in the south of Caspian Sea, and currently I work on the law of the Caspian through the physiology and regarding the osmo regulation or iron regulation. I'm sure you know, gill, kidney, and intestine is very important tissue for one. Regarding those regulation in saltwater fishes, so yeah, generally they have the active and passive osmoregulation processes. What does it mean? They passively gain salt from outside their body because of different concentration from outside their body to the inside. On the other hand, they are losing the water by osmosis, again because of different concentration from inside their body to those. So what they're doing now, they start actively drinking saltwater. Also, they give salt, sodium, and chloride. On the other hand, their kidney excretion dilute like magnesium, sulfate, blah, blah, blah. Also, the kidney should produce very small amount of the isotope. This is the general physiology of the fish in marine environment. Regarding the colloid cell, famous colloid cell in the gill of the general fish, saltwater, they use the colloid cell for saltwater. This process is happening so sodium, potassium, and chloride can enter colloid cell from this co-transporter located in the basstratal part of the colloid cell. And this process is happening because of this famous bond, sodium, potassium, ATPase bond. And this process helping in entering this sodium and potassium inside the cell. Accumulation chloride inside the cell actually help to exit the chloride from apical chloride channel, called it CF. On the other hand, the sodium can exist from porocellular pathway from the liquid between the chloride and I'm trying to simply explain what's happening in the fish. Sure, you know. Lotus linearis. The majority of catfish belong to the freshwater. However, there's a few family of that catfish, like Aridae or Peloticidae family, are found in marine environments, and the Peloticidae catfish are independent invasion in marine environments. The member of marine catfish family Peloticidae, ecologically point of view, is the only catfish. This is the only catfish entering the estuaries. So it's supposed to have the strong urethral fish because belong to the freshwater. There is a few small of this family, like this is unique amongst all of the known teleos up to date because of Yeah, it's actually in the map, you can see the distribution around the world. And also in the south of Iran, in Persian Gulf, we have some species of marine. And in the lower picture, you can see the location of the genetic. And what is the data? Let me give you an example. Imagine you're the fish and you're swimming inside of it. And suppose you use your keel. And one day you found you cannot use your keel. What's happening? The dental organ is a small fleshy external organ close to original papilla, and the parenchymal cell of this special tissue is morphologically similar to the salt gland cell in other vertebrates. What does it mean? It means it's very similar to the nasal salt gland in marine birds, lacrimal glands, marine turtle, lingual gland, sea snakes or saltwater crocodile, and rectal gland. So it was very interesting for us. This is a teleos, but has an external organ and a structure, and probably the function of this special tissue working to the salt gland in other vertebrates. Try to dig in more. The main aim of that study was the genital organ is salt secreting gland and the physiological significance of genital organ in iron regulation, addressed through characterization of brackish water, salt water, and hypercell. Thus, the denser represent another example of convergent evolution of salt secreting gland in vertebrate gland. Regarding the material and results, however, I didn't bring all of my experiment. The fish actually they adjust gradually to brackish water drinkability. Also, they also adjust to higher salinity step. After actual acclimation to these different salinities from the salt water as contour, brackish water, and hybrid salt water, the fish were anestheticized, the blood sample, and also NK activity was assayed in different tissues like gill, kidney, intestine, anterior and posterior intestine, and also the enteroderm. The plasmos modalities, sodium, chloride, potassium, calcium, and also muscle, sodium and potassium, and also muscle water. All our sample. Also, estrone ratio and also we also use the Western blot to detecting or interested protein in different actual tissue. And also we also use the immunohistochemistry to detect actually to localize or interested protein in different tissues. We also did some actually molecular genetic stuff regarding our extraction from extracted, making real-time PCR and results and discussions. In the experiment, in this table, you can see the summary result of the ions and osmolality, so muscle different sizes. If you look at the right side column, you can see the acclimation to hypersalinity resulted in increased gross osmolality and also ions, including sodium, potassium, chloride, and also the muscle and decreasing the muscle water content. All of these results represent to us those regulative challenges and systemic dehydration happening due to water loss by osmosis disturbance from the internal flush. Brackish water, regarding chloride and also SIR, actually it means sodium brackish water, so chloride level were better regulated and the result in strong ion migration represented to us in the metabolic acidosis is happening in brackish water. Regarding NK activity, if you look at this graph, in the left side, you can see big difference between the denture organ to other tissues. On the right side, you can see the NK activity measure in the gill, and the result was interesting because in the lower and higher salinity, the activity was lower than middle one, control. Anyway, when you look at actually the denture organ NK activity, the result was similar to the gill. What does it mean? It means in brackish water or hypersaline water, the NK activity in the denture organ was lower than the control. So it was a strength for us. And actually, we measured the weight of the denture. The results show to us expression of denture organ NK activity relative to the body mass result to denture organ mass. Thus, total denture organ NK activity was higher, indicating higher overall capacity and higher salinity. Regarding the gene expressions in different tissues, including gill, kidney, intestine, and also denture, the results show to us in brackish water higher memory expression of the CFTR and SS26A6A regulate role has a regulatory role in colloid and bicarbonate transporting, suggesting a function regulatory role in acid-base regulations. In hypersalinity, higher memory expression of the CFTR in anterior intestine suggests a role in recycling colloid in parallel with apical chloride bicarbonate exchanger to increase bicarbonate excretions. And in denture organ, in hypersalinity, lower expression of CFTR and also carbonic antikel 17 for higher expression SSE26A6A in denture organ suggests the possible contribution of the denture organ. Summary of the Western blot result in denture organ. Actually, the results show higher expression and sodium potassium 2 chloride expression in denture organ hypersalinity. Regarding carbonic antitrust, the results show in hypersalinity, the expression of the protein was lower than other salinities, like brackish water. Regarding the famous proton pump, saltwater control show lower actual expression than both brackish water and hypersalinity. All of these results represent changing proton pump and carbonic antitrust protein and memory expression in denture organ with SSE26A expression, suggesting the possible contribution of denture organ in acid-base regulation. The result of the heat shock protein 17 showed to us higher protein expression in hypersalinity, representing the ester situation, particularly in denture. Picture representing very interesting staining pattern of NKA and NKC together. What does it mean? If you look at this picture, you can see two different types of the cell. One cell represents to us orbit-to-pure shape cell, principal cell. Actually, orange color the mix of the green belonging to NKA and the red belonging to this one. They mix together and produce orange color. And also, there is another cell detected in denture organ, only representing NKA. This pattern independent was to salinity. This is actually general structure of denture organ. So NK activity showed to us very high NK activity in denture organ compared to other tissue like kidney, intestine, anterior or posterior, or the gill. Also, immunohistochemistry staining showed to us co-localization of the NKA and NKC together, parenchymal cell, and also localization of CFTR colorate channel in apical part of the parenchymal cell. Actually, this pattern represents to us localization of the famous actually colorate cell in the gill. The colorate channel means the presence of conserved secondary active colorate secretion mechanisms found in other ion transporting epithelial of salt secreting gland vertebrates. Some part of this is already published in physiology. Regarding the gill, so it's actually using double immunostaining of the NKA and NKC together and plus represent to us very few NKA reactive cells present and were heterogeneously distributed within the filament epithelium and absent from the lung. NKCC and CFTR expression was found on the see in the picture by arrow. NKA reactive cell present not in the lung. Also, very rare find of NKA cell that co-express in NKCC. Also, very lower NK activity inside the gill compared to the maybe represent to us the secondary role of the gill. Teleos fish, because the gill, it seems the gill has a secondary role. And maybe they're representing similar relation between the gill and rectal gland of the plasma branches. In summary, our result increase our knowledge regarding the basic osmo and or salt regulation mechanism in unit marine. Consider form and function of salt gland through the evolution of the marine vertebrates suggests the conservation of genetic mechanisms leading to development of this style. Physiological, ecological, ultrastructural, and all molecular actually localization of NKA and NKCC together or study represent to us dentary salt secreting function. Also show to us conservation of similar mechanisms of ion transporting secretory cell of other vertebrate salt. In the right graph, you can see the summary of the result localization of the different protein has role in ion transporting in different part of the gill and also the entire organ. Thank you for your attention, and if you have any questions, I'm here. I just try to summarize some of my results because of the time, and also I was running because of my problem in internet. Thank you.
All right, thank you very much, Salman. Interesting stuff.
Thanks.
We had a little audio issue, a little feedback while you were talking, but I think we got most of that. If folks have questions, feel free to put them into the chat box, or you can unmute yourself and ask Salman directly.
Thank you again because of your time and attention.
Any questions out there? All right. Well, thank you very much, Salman.
Thank you.